12.5 talks about mathematical induction. To really grasp mathematical induction, I need to talk about series just a bit. S stands for sum. If I want to add, this is where you start. You plug 1 in, and this is where you terminate. Well, if you're only adding one term, you really don't need a formula. If you only have one term on a list of numbers, which is a sequence, then the sum of the first term is really the first term. S sub 2 is the sum of the first two, a sub 1 plus a sub 2, and that is, you plug 1 in, you get a sub 1, and you throw 2 in after that, so you keep on throwing those in until you get to 2, you stop. But you notice, that is S sub 1 plus a sub 2. We don't see that yet because we haven't seen enough of those. Well, let's see more. S sub 3 is the sum of the first 3 terms. That's what that means. That is, n equal 1 to 3. Start with 1, 2, and when you get to 3, you stop. But do you notice that those two right there are those two right there? So, since that's S sub 2, can't I say that's the previous sum of 2 plus a sub 3 plus this extra term? Why would I want to do that? Because I don't want to keep on adding those over and over. Look at S sub 4. Instead of adding the first term, the second term, the third term, and the fourth term, I know the first 3 terms are right there. That's really S sub 3. So can't I say, why don't we take whatever we got out of this and add the next term to it? If I want to find S sub 5, look at that. Well, instead of adding those, isn't that right there? Isn't that this sum right there? I got it to be a certain formula, which is S sub 4. Just add the 5th term. Now, what if I want S sub 50? Well, instead of adding 50 terms, if I have the first 49 terms, I'll say take the first 49 terms and add a sub. How do you find a sub 5? A sub n is right there. You just plug that in. So can I say with ease that S sub 6, without listing those, is really a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5? Isn't that this? Plus, how do you find a sub 6? Find the general term and throw 6 in there. In general, if I know the sum of the first k terms, so this is a sub 1 plus a sub 2 all the way to a sub k. If I want to sum from 1 to k plus 1, well, hey, isn't that a sub 1, a2, a3, a4, a5 all the way to a sub k, which is this? Plus, how do you find this term? Find the general term and throw a k plus 1 in there. And I'll demonstrate that as we do the problems. So, let's talk about mathematical induction. Oh, I didn't label it mathematical induction. How did that happen? The principle of mathematical induction. Let me do that and come back to save time. Okay, I think we fixed it. So let's see. Principle of mathematical induction. It says let S sub n, we know what S sub n is. S sub n is the sum of the first n terms. Let S sub n be a statement depending on n, where n is natural numbers, like counting numbers. If you say count to 10, you start with 1. If the following two statements are satisfied, you have to show this. Those two you must show. 1. S sub 1 is true. Kind of like what I did in the beginning. Very simple. Throw 1 in for n and see if it works. If, so this is an assumption right there. If you assume that S sub k is true, what's S sub k? The sum of the first k terms. That one right there. If you assume that this formula they're going to give us equal to this. then you want to show s sub k plus 1 is true. So if you're able to do 1 and 2, then the assumption is that, or the conclusion is that, not assumption, the conclusion is that this original statement is always true. So let me start. A bit confusing in the beginning, but it's the same process. And I'm going to color code those. So let's look at that and correlate those to what we did in the beginning of the section. I'm talking about this. This says, use mathematical induction to prove that the formula is true for all natural numbers n. A. Prove that 1 plus 5 plus 9 plus all the way to 4n minus 3 equal n into 2n minus 1. So what does that mean? This says, prove that this sum equal to this formula. This is your s sub n. This is a sub n. That is a sub 1 plus a sub 2 plus a sub 3 plus a sub n is right there. So, if I take 1 plus 5 plus 9, we're adding 4 plus 13, what is that right there? That is 10, 23, 28. How about if I want to find that's s sub 4? If I want s sub 5, that is 1 plus 5 plus 9 plus 13 plus, if you add 4 every time, right? Add 4, 17. Do I need to add all of those? Isn't this sum 28? Plus, how do you find 17? Well, that's a sub 1, a sub 2, a sub 3, a sub 4, throw a 5n. That's how you find a sub 5. I'm going to erase all of this. If you put a 5 in there, isn't that 4 times 5 minus 3, which is 17? So isn't it easier just to take what I added first and just add one more term to it? How do I find the term? By using the general right there. What if I wanted to find s sub 6? So does it make sense for me to go 1 plus 5 plus 9 plus 13 plus 17 plus 21? And does it make sense to keep on adding those? That's a 10. That is 20, 30, that's 40, 51, 56. Do all of that sum. Can't I say just take the previous was 45 and add 21 to that? Did I add those wrong? 20, 30, 40, 50, that's 66, my mistake. And that will be 66. Isn't it easier just to take the previous sum and just add? How do you get 21? Take the general term and plug in. You said that is s sub 5 plus a sub 6. Throw a 6 in there. So s sub 5 is 45 plus a sub 6. A sub 6, put a 6 in there. 24 minus 3 is 21. Now, that's the left side. Let's talk about the right side. The right side, you'll notice there's a formula for that. So, for s sub 4, throw a 4 in there. Isn't that 4 times 8 minus 1 is 7. And 4, 8, 7. That's 28. Do you see that? How about here? S sub 5. What is S sub 5? The right side is the formula. It is 5 into 2 times 5. 10 minus 1 is 9. That's 45. Look at that. How about S sub 6? S sub 6 is, go to that formula, throw 6 in for n. 2 times 6 is 12 minus 1 is 11. Isn't that 66? Now that we get an idea of how this is playing, well, let's see how we're going to do this, but not with numbers, with variables. So, and I'm going to list this out for you on every problem so you could see it. But that's the idea. So all of this is not needed, but let's talk about this. Let's talk about this assumption. So we're calling this S sub n. It says, let S sub n be a statement. There it is. 1, we want to show S sub 1 is true. What does that mean? Well, S sub 1, You could take the first term on the list because if you recall, S sub 1 is simply A sub 1. So two options. Either you take the first term or you throw a 1 in there. It makes no difference. Equal and throw a 1 in there. You must show this. Secondly, you're going to make this assumption on every problem. You're going to say, suppose, or assume, or let. Suppose the statement is true for natural number k. That is, suppose if I look at this, 1 plus 5 plus 9 plus 4k minus 3 equals k into 2k minus 1. Then, what is s of k plus 1? What would that be? That would be 1 plus 5 plus 9 plus 4k minus 3. I want the next term. How do you find the next term? Replace this k by k plus 1. Equals. On the right hand side, if this is s sub n, if I put s sub k plus 1, don't you put a k plus 1 right there? The right side, you're allowed one step and one step only. And that step is never to FOIL those. It's always to keep them in, just to simplify that piece. Plus 2 minus 1 is plus 1. Your goal now is to show me mathematically. Don't force the equation to equal. Make sure it folds mathematically that the left side is going to give me that green part. Well, look, I made an assumption that this sum right here equal this. Hey, that's the idea I was talking about. If I want to find s sub k plus 1, isn't so s sub k plus 1? Didn't we agree that was s sub k plus a sub k plus 1? S sub k is what I have highlighted in yellow. What does that equal? That equals k into 2k minus 1. Plus one more term. That is 4k plus 4 minus 3 is plus 1. Alright, what are you going to do now? You're going to work with this left side until you get the right side. You can't work both sides. You're only allowed one step of simplifying the right side, nothing else. You can't use that for anything else. Just be careful. So this is 2k squared minus k plus 4k plus 1. This is 2k squared plus 3k plus 1. If I factor that, that is 2k and a k, and a plus 1 and a plus 1. There it is. It checks. Once you get the right side, you say, well, you could put this symbol, and you say, therefore, and you restate the original statement. Now, be careful. You can't use n in place of k up there. It has to be k. And this is your first official proof that you do. That's your conclusion. You always restate the original conclusion. On your homework, if you're not going to list everything that you see up there, I'm going to give you a 0 for that homework. And the point out of that 0 is warning you that this problem on a test, if you don't write everything that I see, I will give you a 0 on the problem on the test. So be really careful with this. I want to see everything that I wrote down, you have to write down. Let's do another one. How about this problem? Well, where do we start? We start with, let this be S of n. S sub 1 is let n equal 1. Either you take the first term or you put n equal 1 in there. Remember, that's a sub n. So that is 2 equal. On the right hand side, put an 1 in there and show that those are equal. You have to do that. Second, that step number 1 is done. One more step. So suppose you assume this is true. Suppose the statement is true for natural number k. That is, if I relist the same exact thing that I see, let me use a different color. If I take 2 plus 3 plus 4 plus k plus 1, that equals k into k plus 3 over 2. Now what? S of k plus 1 would be the first k terms plus one more. How do you find the next term? There is a sub k. What is a sub k plus 1? That is k plus 1 plus 1. And what's that going to equal? On the right hand side, you simply plug in whatever that is. Throw a k plus 1 in there. You're allowed one step on the right, and that's never to FOIL those. You can never FOIL the right. You can only use the step to combine those and show what that equals. That's about it. You can no longer touch the right side. Now, I made an assumption. I assumed that this sum right here equal this. Isn't that sum right there? Can't I replace that by my assumption by k into k plus 3 over 2 plus, isn't that k plus 2? So, if I get a common denominator, which is a 2, isn't that k squared plus 3k plus 2k plus 4? Isn't that k squared plus 5k plus 4 over 2? Isn't that k plus 4 into k plus 1 over 2, which is exactly that? You're done. You could do this, whatever you want. And then what? You relist the original statement. That's an official proof. And make sure that you're listing everything that I'm telling you. And that's pretty much the whole problem. I have 3 more that take a bit of time, as you see. I'm going to do those 3 problems on the next lecture video. That's not going to be as long, but there it is.